I was wanting to do another video on the KerberosSDR, but this time actually use it for direction finding. I also had purchased a program a while back, hadn't really used it that much, called RDF Mapper, and I wanted to show how to integrate the two. Unfortunately, I don't have my Raspberry Pi here with me, so I have DragonOS LTS installed to a laptop behind me here. I'm going to go ahead and temporarily replace the RTL-SDR drivers that came with GQRX. What this is going to do, it's going to replace the drivers for the RTL-SDR with some drivers built specifically for the KerberosSDR. In doing this though, I'm going to definitely break probably a few things like GQRX and the normal use of the RTL-SDR, so I'm just forewarning you. This is, if you wanted to use this particular build that I've put together and you wanted to run the Kerberos on it, until the developers merge kind of the KerberosSDR and the RTL-SDR changes together, it appears to be one or the other. So this is the KerberosSDR, or an image of it I found real quick on the KerberosSDR start guide. Here on the left, like I said, I have one behind me here. It actually is plugged in to the computer right now, and you'll see where it will come up and be recognized 4 different devices. But what we need to do is remove the RTL-SDR and the, let me think, librtl. Yes, these 2 packages. You're going to see it's going to, well, I'm actually surprised it didn't, normally it removes other dependencies. Now that we have that removed, we can hop over here to the quick start guide. We can install all the dependencies. And we don't need, it's actually Wonder Shape but really don't even need that. That was meant more for the Raspberry Pi. We'll go ahead and remove what it's saying here as far as the Python numpy. This is where it's going to start breaking some things. It's going to remove Kismet. We'll install every one of these packages. We'll go ahead and, while that's finishing, all right, I went ahead and installed test resources. Let's come back up. Probably not going to have an impact on anything, but I'll run that again. I'm going to change directory to user source. We'll grab the specific KerberosSDR drivers. go ahead and grab a few more packages, which should already be all installed. Yes, they are. We'll drop down here to our user source directory and into our RTL-SDR Kerberos folder. Sudo make directory build. Sudo make. This will blacklist. I don't think this is needed in the case of how we're setting this up right now. A lot of this was already done previously. So now let's go ahead and test the tuners. Okay, we can see we've got it back up and working. Let's change back to our user source directory. Now we're going to install the demo software here. Change into the demo folder. Let's see, let's take a look at run.sh. All right, it's going to run on basically the local host port 8081. I don't have I'm not concerned with a wireless card in here, but if you were setting up this source code on another computer, you could actually comment out the IP address up top, and if you had a WLAN 0 interface, you can uncomment all of this, and then it will be up and running on your wireless card. I'm not going to change anything in here. So at this point, we should be able to, let's go ahead and okay. Okay, now that we finished the compiling, I'm back. I made some changes here. We're going to run the software. This is both going to run on a web page at port, actually it runs on 8080 and 8081. There's two different parts that are actually running, and then it's going to pop up this interface here. If we go to localhost port 80/init, you can see some of the very same settings that you can see in the software here interface here. So once you get this up and running, you want to sync your radios, and you should do it without antennas. With the terminators basically on is how they explained it here. You can run through exactly what I'm doing without the antennas attached. I am going to go ahead and say I am doing it with it attached, just to speed up and show you how we can make this work. So I have a antenna array behind me, just the standard telescopic antennas, spaced probably 8 to 9 inches inter-element apart from one another. Not the most ideal setup. Again, this is just a demonstration purposes here. You can read more about how to do the math behind setting up your antenna array based on what frequency you want to direction find on. But for this, I am just going to pick a frequency, an FM station that's around here. I'm going to go a little higher than 15.7 on the gain. I'll set a uniform gain here, and again, you can read about it here where it talks about you want to set your MSPS about a 1.0 for direction finding, set your gains higher than 15.7. We come down here, we enable DC compensation, leave your FEAR tap size as 0 and decimation as 1. Go ahead and enable the spectrum display, start processing. You can see that it runs a lot faster on a computer versus the Raspberry Pi. I do have one issue with one of my channels. I think it's the antenna. I'll get that changed out. Don't have a real good signal. So go ahead and, because the laptop's quite a bit more powerful than the Raspberry Pi, I'm not too worried about stopping or disabling the spectrum display. But if I come over here to sync, I enable the sync display noise source. You'll see we want to get everything synced here. So I click on sample sync once, calibrate sync, give it a little bit. I'm looking for everything to kind of flatline, come down to one solid line here. We're good up here. So we can come back over to calibration and spectrum. We'll stop the processing for a second. Come down here, so we've synchronized and calibrated the radios. Now we want to get down to doing the actual direction finding. So I've got the antenna array hooked up, spectrum display is on. We can now adjust the FEAR tap size, filter bandwidth settings. They give you some examples here how to really fine tune that down. Decimation value must be powers of values of 2 will have the bandwidth. So let's just go with their typical FEAR tap size of 100. Let's see, start processing. You'll see how this brings it down to the frequency that we're actually looking at. So my understanding is the RTL-SDR blog site is working on some modifications for future versions. I actually have the version 2, I think it is, of the KerberosSDR. They're going to make a new version that will allow you to sync without removing the antennas. So I think that will be really handy, so you don't have to take them on and off. You could be changing the frequencies and letting the system resync on its own. So let's go ahead, come over here to DOA estimation. I've got a circular array. Spacing, again, I'm not going to get it fine-tuned right now. Let's go ahead and enable. I recommend using the music method. And so now we're doing our DOA estimation. We can come back over to, let's see. Actually, we can pull up our web page on 8080/init. If you come over here to DOA estimation, you're going to see all the same settings that I just set are on. We see we're updating. And let's just take a look at the compass. So again, I didn't really fine tune the antenna array. It's inside a building near a window, so you're going to have a lot of signals bouncing off, and or maybe obstructions. But you see we're generally pointing over here. So we've got the Kerberos up and running. I want to go ahead and stop processing. So that's just a brief overview of the Kerberos SDR and getting that part up and running. What I also want to show is how to incorporate the Kerberos SDR through a script that was written to include it into RDFMapper, which is another third-party bearing server that allows you to visualize the map with the lobs, and it was actually made for another this Doppler RDF system, but it's been adapted to work with the Kerberos SDR. So this is roughly $25, I think, American dollars for this program. It's I know I normally stick almost everything in the source folder, but I've just downloaded it, sitting here. I've had it for a while. I've got a bearing server folder sitting here, the actual file that will run, and then a PDF that comes with it to explain kind of how to use everything. So one thing we're going to need, I mean, you can put a full-blown web server, Apache or whatever it may be, PHP web server on your system to get this up and running. But all I'm going to add is now I've already installed this. It'll pull down a couple additional packages, and I'll show you why we're going to use this. But we've got that down, and any associated packages will change to our desktop, to the RDF Mapper bearing server. And then what we want to do is run sudo php dash capital S localhost 80. That's going to run the RDF Mapper bearing server, the actual server portion of it. We'll move that out of the way for a second. So we've still got our Kerberos SDR software running over here. We've got the bearing server running. Now we need to change directory desktop. I've made RDFMapper executable. I've also, just to remember, I've made the data folder in the RDFMap bearing server. The example that they give is just chmod 777, the data and the file that's located in data. All right, but what we're going to do is run the RDFMapper program. It's going to run. It's going to pop up a browser on localhost 8000. Just with some default settings here of the developer. Now, remember, I have the RDFMap bearing server running as well, and that is on localhost. So it should be interacting. Let's take a look at the let's see. Let's take a look in the RDFMap bearings server folder data. So the developer's got some example stations that he's labeled in here. Let's try and put one of these in. TSTA2 add, and so now we see that the bearing server is working with his executable here, pulling in some of these example stations that he's pre-programmed in here. Now, what I want to do is, let's close this. What I want to do is use this script from the RTL-SDR blog that uploads bearings from my KerberosSDR to the RDF Mapper. So let's see how we can do that. Let's go ahead. We will pull down this repository. We'll put it in our user source. Okay, and we want to make sure we have all prerequisites installed. So we'll change into our PY RDF Mapper folder. Make sure we have everything. I'm going to clean up some of this stuff so we know that the KerberosSDR software is still running. We know the bearing server is running. And we know that the actual RDF Mapper executable or Linux equivalent is running. So we'll minimize that. Okay, we have everything installed we need. Go ahead and use nano. Localhost. Localhost. Okay, now that we have that saved, I didn't change the Latin long or any of the other information that's in there. So let's go ahead and run. All right, so we've got this running now. Let's see. Let's remove this. Let's see, let's add this station. So we've got, here we go. We have everything talking, and this is all on one computer. No Raspberry Pi. We have the Kerberos software running. We have the, let's see what we got here. Well, you know what? Let's see. It wasn't running. So now it's processing. Now there we go. All right, see? Now it is, I'm looking at it over here. Now it's running real time in the RDF Mapper software. Okay, so just to recap, we took DragonOS LTS, we removed the default drivers for RTL-SDR, we replaced them with the Kerberos drivers specific. We installed the KerberosSDR software. We installed the all the prerequisites, and then we went ahead and got the RDF Mapper up and running. Everything is talking to one another, and we're now displaying the lobs in this RDF Mapper with our stationary DFing platform. I have not got to try it yet, but the actual KerberosSDR app that can run on an Android phone now has the ability to export the heading, the GPS information, and more up to RDF Mapper. So in theory, you should be able to move and have all the lob information being displayed in real time on a map. So where I see benefit in that is, especially if you get more than one direction finding sensor, you have them all networked, and now you're all displaying these lines of bearing at a signal in real time. Is going to really help you do some direction finding. Okay, that's all I have